Okay, they want us to graph these two lines, right? And again, you have everything at your disposal. You have Desmos to check this on. So I'm just going to graph really quick and dirty graphs here, right? So the first one, the y-intercept's -3, 1, 2, 3, right? And it goes downhill at a slope. So let's just, I'm just winging this so you can get an idea for what the shape is, but you can check this on Desmos. The second one has y-intercept of 1, right? And the way, I'm not, doing any math in my head. Here's the y-intercept for the first one. Here's the y-intercept for the second because it's in slope-intercept form, right? And this also has a slope of -4, so that means it goes like this. So clearly they gave us two parallel lines, right? They have the same slope. So where do they intersect? For A, they don't, right? They do not intersect. And clearly they do not intersect because they're parallel lines, right? And they have different y-intercepts. So B, solve the system. Now, remember, when we solve a system of equations, we're looking for the point of intersection. So already we can kind of guess what's going to happen. So equal value method says since they both equal y, then they must equal each other, right? -3 equals -4x plus 1. We add 4x to both sides, and we get -3 equals 1, and -3 will never equal 1, so there's no solution. And I can write no solution, right? Because no matter what, there's no value of x that's going to make -3 equal to 1. So there's no solution, which makes sense because the point of intersection would be the solution, but we know they already don't intersect. So and then C, explain how your graph and algebraic solution relate to each other. Okay, and they relate because on the graph, which is here, right, they don't intersect, and then algebraically there's no solution, which is the intersection point. So I won't write that since I just explained it.